Let me backtrack a little bit. When I was talking about quantum mechanics, one of the problems is that the theory doesn't really make sense. Some people call it the best theory you've ever had in science. Maybe it is. I don't think it is myself, because it's it's inconsistent with itself. And this is because there's an equation called the Schrödinger equation, which tells you how the quantum state evolves. And it's very deterministic, like Laplace and all these other people. If you know what the state is now, and you know what the things you put into that is to say the matter or whatever it is you're talking about, what's called the Hamiltonian, you feed that in, then the Schrödinger equation gives you a deterministic evolution. If you know what the system is now, then in 15 minutes from now, you would be able to tell what the system is. However, it's not the whole story, because the matter doesn't satisfy the Schrödinger equation. When the system is nice and small and uncluttered, then it seems to. When it gets too big in some technical sense, which I could say more about, but not everybody agrees on what that means. When it gets too big in some sense, then it doesn't follow the Schrödinger equation. Schrödinger got very upset about this, quite reasonably. What it does is that the wave function, that's what the Schrödinger equation is talking about, how the wave function evolves, and the wave function is describing the world according to the theory. There is a thing called the collapse of the wave function. So it doesn't follow the Schrödinger equation. And usually this is considered by when something or somebody makes a measurement. Now, in the old days, it was quite often thought of that a measurement or an observation, the word observation was often used, that suggests that some being comes along and looks at the system, and that's making an observation on the system, and that's the point at which you collapse the wave function. Probabilities come out, it's not a deterministic equation anymore, and it's a thing called the Born rule, which you have to adopt. Instead of the Schrödinger equation, you change your mind and say, okay, well, let's use the Born rule instead. And this changing of the mind used to be considered to be the effect of a conscious observer coming and looking at the system, looking in the sort of broad sense. Now, my view is quite different from that. It's almost the opposite. I'm saying that there is something out there in the physical world which at the outset doesn't have anything, at least not manifestly, to do with consciousness. It's the way that the world operates, and this happens to do with what happens when you try to combine quantum mechanics with that other great theory of 20th century physics, Einstein's general theory of relativity. Now, you see, there's a big school of thought which says, oh, well, we haven't brought them together yet. We need to quantize gravity. We need to bring gravity theory, Einstein's curved space theory of gravitation, you need to bring it within the scope of quantum mechanics. And that's the idea. Quantum mechanics is supposed to be the ultimate, which you bring, but without mentioning that theory is inconsistent with itself. Now, my view is the opposite, that to make it into a more powerful theory, which agrees more with the way when it doesn't follow the Schrödinger equation, what does it do? That's when gravity becomes important. And there are arguments one can bring to indicate this is quite plausible. That when gravity becomes too important in your system, then the state does not follow the Schrödinger equation, and it starts to jump in the way that the Born rule tells you. You get probabilities, you don't get a deterministic evolution. Now, I do believe that that's where we should aim for, and that's where, if you like, creativity will come in, because we don't have the theory yet. So it needs creativity to go beyond current theories of physics to introduce some new ideas which are indicated. You can see sort of aspects of the new scheme. It must have this effect and this and this. So you can see some things it's got to do, but we don't have the theory. Now, is that creativity? Well, it's creativity if it's not acting within the scheme that we had previously. Then you've got to be creative, because the theory we had previously doesn't give an answer here. It doesn't tell you what the collapse of the wave function is. It just says, you do it. And it doesn't say when. It just is a very incomplete picture. People like Einstein and Schrödinger and Dirac were a bit more polite than I am. They say the theory is incomplete. I'm saying the theory is actually self-inconsistent, so I'm a bit ruder than they were. But it needs something to be done, and that's where a bit of creativity absolutely is necessary.